So I suppose that most of you who wanted to join are available here. I'm sharing the screen now. Are you able to see the screen?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, fine. Okay. So, firstly, let me tell you that there was no any mistake in the logic that we were working with. So, the fact that we did not write flow chart for it is not responsible for the kind of problem that we were facing, but it was somewhere else. And let me highlight the problem where it was, and then you can tell me that what was the problem. Okay, so this is the line that I have corrected right now. Okay, so obviously I can write out, even this is also fine. That won't make any change. So this is also going to give me correct answer. But what we had written yesterday was this. So is there anyone over here who is able to see what was the problem in this?
Ma'am, I think the last term of the defined function is only getting multiplied by h.
Yes. So actually the problem is that we have defined fx as, sorry, I'm so sorry. We have defined fx as a macro, and since we have defined it as a macro, then whatever that we have written in front of fx, it is getting copy pasted as is. Okay, wherever we are calling that fx. Had it been a function, then we wouldn't have landed up in that problem. But now, since it is a macro, then whatever that we have written over here in this macro, that statement is getting copy pasted. Okay, so when you copy paste this entire stuff over there, then what is happening? Multiplication of h, that thing comes only with the last term, which is this m7 multiplied by x raised to 7. Are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Are you able to appreciate what was the problem?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
Okay. So I was also kind of surprised to see whatever was happening yesterday, because we were seeing that almost 3,000 number of segments were required, which is obviously not anticipated for such kind of small non-linear function. I mean, it's not that small I mean,
Excuse me, ma'am.
Hi, yeah, Paras, go ahead.
मैम यदि हमने उसको डिफाइन फंक्शन डिफाइन किया होता तो क्या हम मैक्रो लिख पाते उसमें?
तो ये प्रॉब्लम नहीं होता क्योंकि कॉपी पेस्ट नहीं होता है। अगर हमने ये फंक्शन डिफाइन किया होता एफ ऑफ एक्स, तो क्या हो जाता है, ये एक्स की वैल्यू वहां पे वी वुड हैव पास्ड दैट वैल्यू ऑफ एक्स ओवर देयर। ओके, तो वहां पे वैल्यू ले जाके that execution is done over there itself in the function, and function returns what is the total evaluated value of this expression. So inside the function, this expression will be evaluated and the final value will be returned if you write down the function.
तो array define कर सकते थे फिर हम उसमें function में.
You can pass array to that function. So we could have written it as, we could have passed x and m like this. Okay, we would have defined int fxm, and then inside that function, let me check that what is the syntax for this one. Let me just check it out. And then inside this, I would have said that this, let me pass it to something. I'm writing it as L is equal to this, and then towards here, I'll be returning L. It's not int, I'm sorry. Wait. and I'll be putting this closing bracket over here, which is this function expression. Okay, if we write it down in this way, then it shouldn't give us problem. Then, however, we will have to pass m as well to function. Okay, so wherever you have defined f of x, you will be writing down f of x comma m.
It is written as f of float x comma float m.
Yes. This is also required over here. So float x. So you need to mention data type as well. Float x comma float m.
Ma'am, M is an array, so we have to put square brackets also.
C++ is actually, and it really sucks when you want to write it down a big code. It's really difficult using this. You have so many things to take care of, and in such cases, you are likely to end up into problem. Okay, so if you do so, then hopefully it will solve our problem. Okay, this is one way of defining a function. Okay, the way that I used to resolve our problem was I just put one bracket over there for that fx. Wherever we had written fx, I wrote that fx inside a bracket, and to that I multiplied by h. Okay, that solved our problem. But this also is able to solve our problem. Try to see whether it's solved. So I hope it is clear how to write down a function. Okay, I'll write down this in a different.
Ma'am, for arrays, don't we write square brackets after words, not on the variable?
M should be out of square brackets.
I don't know how it is done in this one. Okay, so is it out of this?
Yes, ma'am, M should be out of square brackets.
It is like m square brackets.
M square bracket it. Is that how am I supposed to do this? Just a minute, students, just a minute. I'm so sorry, I had to attend something. Okay, so let me write down this as function. Okay, in that I have done this change. Okay, so
Ma'am,
yeah,
ma'am, in line 5, can we use F instead of L?
you can write down anything over here.
Ma'am, means the same as the function variable.
I don't suppose there should be any problem in that. You can give it a try.
Okay, ma'am.
Okay, so every language has got its own set of rules, and you have to follow that. I have written D over here. I'm mistaken. I don't know why.
L
I
is
did.
also a variable
So are we using L also somewhere?
inside the function.
So we will have to define this. Load L, and then that will be equal to this. And then that L is something which we will be returning back. But if we do this way, I doubt whether will it not pass only 8th value in that M array?
But ma'am, M8 does not exist. It symbolizes whole array.
So let's try to give it a try. Okay, whether it works this way. Okay. Otherwise, we will be working with the way we were doing it.
It will work because I used the same syntax.
Okay, fine. The syntax is really weird, but anyways, we have to follow that. So wherever we are calling f at all those locations, we will have to make this change.
Ma'am, I just checked on the internet. Whenever we are passing an array, like in line number 31, you are passing an array, right?
Hmm.
So we don't have to mention the size of the array. You can just write m and not even the square brackets. But
Okay.
when the function is receiving the array, you need
That
to write
time.
m and square brackets, not the size anymore.
Okay, so function needs to know that how many number of array elements are coming, and it is an array, it is not a single variable. So function needs to know over there where function is defined. Otherwise, while passing, we don't need this. Okay, fine. So that is the syntax, which is different than what MATLAB is having. So I suppose we are done with all required changes. And one more thing, that m is not float.
Ma'am,
M is-
here in line number 3, m के बाद square brackets में 8 लिखने की जरूरत नहीं है, सिर्फ square brackets होगा वहाँ पे.
Acha, even how many number of elements are there, that is also not
Yes,
required.
ma'am, because the array size has already been defined in main.
Right. Yeah. So array size has already been defined. So m is array. That's the only stuff which is supposed to go there. Okay, fine, good. So let's try to give it a try and let's try to see whether it works. I hope it should work. Yeah, at least there is no any. Oh, there is an error. F cannot be used as a function. Why? Is this? I'll check it out. Okay, fine. So I'll check what is the syntax for function. Okay, and then we'll give it a try once again. Okay, so let me come out of it as of now. Okay, it's really absolutely weird in this C++, and we'll open that earlier file. Let me close this for time being. Let me open the earlier file.
Ma'am, I think throughout the program we need to use L instead of F.
Okay, I'll check it out and I'll let you know about
Ma'am,
what
we have
exactly
declared
is
f as a float variable. I think we should delete that.
Is f a float variable?
Yes, ma'am, we have declared it line 10.
Okay, we already have f as a float variable. That's why it was causing problem. Good. Okay, fine. So that must be the error. But anyways, we'll be able to solve it in this fashion as well. Okay, so let me first of all try doing it using macro, and then we'll run that program as well. Okay. This should run now. Okay, so let me give the same number that we were giving it. I suppose I'm right. Yes, 2 beginning, 5 end, and this is what is the value of integration. And a number of segments which we ended up with are 63, which are far less, right? And whatever, just check it out if it is nearby to the actual answer.
The actual one is 10813, 101813 something.
101813. Okay, fine. So in that case, we will have to refine. Now, in this case, if you refine this tolerance further, okay, then you will see that the final answer that gets refined, and it won't be too different. So whatever answer that we have obtained for tolerance 1, that is not far too different than whatever that we'll be obtaining for tolerance 0.1. However, in the earlier case, when we were running this program, we were getting erratically different answers, and that is obviously not supposed to happen. So our numerical integration schemes are obviously not that bad. So you shouldn't get that weird answer. इतना गलत नहीं हो सकता. This. Just check it out if the number is right. So we are closer by, right, than what we were. Are we not?
Yes, ma'am.
Yes. So refine it further and you are going to get a better answer. But let me tell you that you won't ever get exactly the same answer. Because it is not exact integration, you are bound to get certain errors in this. So how close is the answer?
Yeah, 873 is the online one.
Yes. So number of segments are 451, which we required to get this answer. Okay, so this is one of the very basic numerical integration schemes. There are far more better numerical integration schemes than this. Okay. However, just for the demonstration, I have picked the simple scheme, which is called as a trapezoidal rule. And we have carried out this using macro, and I'll just check it out that somebody was just now saying that since we have defined f over here float, so that was the reason why we were not able to run this program appropriately. So now let's check it out. Yes, at least there are no any errors in this. Now it is doing what it is supposed to do, right? So it is a function now. So earlier in the earlier program, that fx was a macro, and in this case it is a function. Is the difference clear between what is function and what is a macro? And better way is to go for a function rather than a macro. Okay, but then if you are writing a function in C++, then you have to make sure that you follow the appropriate syntax, where you need to mention all these things appropriately, right? What is the data type of that variable and all. Is this part clear?
Ma'am, in the function, we
Yes,
are
ma'am.
using M1, M2, M3, even though we have not defined it inside the function float f. So why is it
Yeah.
working?
We are actually passing m. We are passing entire m to this function. So now m is taking that, this function is taking that m, and that's why it is able to access all m locations.
Okay.
So it has been granted access to m.
Okay.
So the way it works in case of functions than whatever that we have seen in case of macro, that is very different. Okay, for macro, as we already have talked about, so what happens is that whatever expression that you write in front of that macro, that is simply picked up from there and we paste it wherever macro is being called. Whereas in functions, what happens is that we pass those variables which are required to carry out activities inside the function, and then function is given access to all those variables and what are values which are stored in that variable. So now that function will be able to do whatever that it is supposed to do with the help of those variables, and then it creates it right now it is giving a new variable L. So it is storing that everything in that L, and it is passing the value, and we are now taking that value over here. However, let me tell you that this L variable which we have declared over here, okay, that is local variable to that function. We won't be able to access that variable from this main. Okay, that is local to f. It is not available in main. Main won't be able to use it. Okay, what this thing is doing is it is only passing the value which is there in L. Okay, it is returning that value, and that value we are taking. It will not be labeled as L anymore. Once you are in main, then it won't. I hope it works same in C++, and I'm sure it must be that way. So these are called as local variables. So this L is local to that function.
Ma'am, we do not need to use the L. We can just write the whole statement inside the return.
And say return. Yeah, that is also possible. So you can return entire expression. You can say that this entire whatever is the value of this entire expression is returned. So this also can go out. Okay, so you don't have to carry out even this. You can simply write a return over here, and then this will
And
also work.
put the entire expression in brackets as well.
Bracket, is it required? We'll just check it out because whenever we have expression, then that
No,
expression
it
is
is not
evaluated.
required.
It's not. It may not be required because this expression will be evaluated first. We can just give it a try and just try to see that what happens. Then it was 1, 1, 0, and 2, 2, 5. Yeah, it works, right? So you don't even require brackets over here. Okay, so I hope this particular aspect is clear. And now what I'm going to do is that I'm going to write down a for loop for this. Okay, I'll save it. Actually, yeah, we have written a do while loop. I should have named that as do while. Okay. DW. This is how I should have named that earlier one. And now I'll close this and I'll close this one as well. I will open.
Ma'am,
Yeah.
ma'am,
Go ahead.
inside the function, if we don't return anything and just write f is equal to that expression, then will it work?
It will work, but it won't give anything. So why will you be? There can be certain you can indeed write a function which won't return anything, but then you may print something. You will be doing something with that, right? So whatever activity that you are carrying out in that function, you will be doing something with it. Okay, so there can be a function which will not return anything. But if in this case, if you decide not to return anything, then here, okay, so this when we are writing down this addition, okay, so this addition operator needs two operands. Okay, the first operand is given by this function. Okay, so whatever is the return value of this function is being used as the operand. Now if you don't return anything, then obviously you won't be able to access this function in this way. I mean, this value you won't be able to access. So that function will be called wherever you will be writing f a comma m, that function will be called, but that function won't be returning anything, and hence that value which is being calculated inside the function, you won't be able to use it this way.
Ma'am, so it will be 0 then.
It won't be 0 as well. So it is going to give you error.
Okay, ma'am.
It is not because it is not initialized to 0. Even 0 is an integer, right? So 0 also won't be returned.
Ma'am, but by default, everything is initialized to 0, right?
Yeah, but everything means if there is when you say everything, that every variable, so that variable is either an integer, a character, something needs to be defined, right? So there is
Yes.
no space here, it's void. So how can you initialize that? A void cannot be initialized, right? It's like a
Ma'am,
vacuum.
every variable by default is defined by garbage value, not zero.
Actually, it is a garbage value, but these days, if I'm not wrong, compilers define generally zero values. At least the modern compilers, they generally define zero values these days. But still, we initialize every time whenever we want zero initialization, then we generally do it this way. But even if you don't do it, then these days compilers, whenever you create that variable, they are being especially these variables which are integer, float, and double type variable, they are by default initialized to zero in most of the languages. However, you don't believe in the compiler this much because you don't know whether it is the updated version or not. So it's better if you initialize it whenever you want it. However, as I regarding the problem that Shreya was asking, that it doesn't fit over here because f is not having any return. Okay, so it's completely absent. It's void. Okay, and hence zero also cannot be assigned to it. So it won't even give you zero.
Yes, okay. Thank you, ma'am.
Welcome. Okay, fine. So we were carrying out this activity using this do while loop. Okay, because we were not knowing that how many number of times we are supposed to run this loop. That's why we decided to go for do while. Obviously, we could have done this using while loop as well. Okay, but now I want to carry out the same activity using for loop. Okay, so so we'll be writing down for loop over here. So I'll be changing this to for. Okay. And we are using inside that another for loop. So this is one for loop which I have written inside this bigger loop, okay, which is using I. So obviously I am not supposed to use the same variable over here. I will be using another variable which will be same n variable. Okay, n I'll be initializing it to 2. So in that case, I need not initialize n over here, and I need not even define n because I can define n there. I'm writing that it is int n. Okay. Now I don't know how many number of times I'm supposed to carry out this activity, but I'll take a big number, something like 1000. And in each loop, I'll say that n value is getting incremented by 1. So I can obviously get rid of this final n plus plus as well. Okay. Now what to do with this condition, right? So when to come out of the loop? We are supposed to come out of the loop whenever this condition is met, right? So when difference between f int and f int previous is smaller than or equal to tolerance, at that time we should come out of the loop. Okay. So what we do is that we break the loop. Okay, there is a provision that you can break the loop. You need not run the loop till the time n reaches value equal to 1000. You can still break the loop before that. Okay, even you can break the loop when n is equal to 2 or n equal to 3. Okay, so you will have to write down that condition. So I'll write down if. Okay, so I'll say that if this condition is met. Obviously opposite of this, okay, this condition which we had written for do while, that was the condition which was required to continue the loop. Now I want to break the loop, so I'll have to inverse the condition, okay, that whatever that we had written, okay, when it is smaller than tolerance, at that time when this is done and this is true, at that time break. Yes. So it will check every time that if this f int minus f int previous is smaller than tolerance. Okay, so whenever it will see that yes, it is smaller than tolerance, at that time it is supposed to break the loop, and let's try to check whether it does it. There is one error.
We need to define n outside the loop, otherwise it is not accessible anywhere outside the loop.
Okay. Its scope is also defined. We are writing down this n plus. We'll just comment this. This is the only place we are accessing n, right? Let me comment this. Now it is running. Is it right?
Yes, ma'am.
Yes. So if you are
Ma'am, but
supposed
we
to,
need to.
you need to know that when you are coming out, then what I'll do is, before I break, I'll write down this. Okay. So I'll print this and then I'll come out of it. Okay. And in that case, I will be printing only n, because before increment, we are coming out of the loop.
Ma'am, line number 47 is also not required.
That is just to see anyways, unless it is smaller than 1, it is not going to come out. We are just checking whether the difference between these two is smaller than 1. So that's why if anyone is interested in having a look at what is f int and what is f int prev, you can obviously write down that over here. You can combine that with this 46 as well. So that can be done. No issues. 46 and 47 can be combined together. Okay, so let me run this. Oh, I have given a wrong value. So now it is obviously not going to give me anything which is of my interest.
I think we can backspace while typing.
Before I paint, before I enter, at that time I can indeed do, but after enter is done, then is it possible to do that?
I think yes.
No, ma'am.
No,
it
ma'am.
doesn't work
No.
after entering.
No.
Before entering, we will be able to do. After we press enter, then I don't think. But we can still give it a try. I'll do it only after I enter all these values appropriately. 7, 1, 1. Then I am pressing 0 here. Then 0. There is one more 0, right? Oh, I've again given a wrong number. And see, I won't be able to press backspace. I'm sorry. Okay, so now our
Can't we do the input with spaces? I think that's when I can put a backspace.
so when you have space, then you can do it. Is that so? I don't think it is possible.
I don't know. My
Yes,
compiler
ma'am.
allows it.
Yes, ma'am. With spaces, it is possible.
Okay. Then giving space is better.
And also to make this more user friendly, we can add a for loop, and in that one we can say that m7 minus I will be our inputs. So that we have to type it in the forward
The
direction.
actual number. You can do it that way. Then yeah, you can do it that way. There shouldn't be any issue. You don't even have to write down that loop. So you can change the way you are taking input, and accordingly you can. This allows. Yes. So number of segments that is being printed before printing value of integration, and this is being printed before that break is executed. However, condition is met, but break statement is yet to be executed at that time when just before that break value in n is equal to 63, and thereafter loop is getting broken over there. Okay, so there won't be any further execution of the loop. Is this point clear? It's very important for all of you to understand it. So is everybody able to appreciate that what is happening in this?
Yes, ma'am.
What about others?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Good. Is there any query pertaining to it?
Excuse
Ma'am,
me, ma'am.
suppose there is an integration which uses more than 1000 number of segments, then you will have to use an infinite loop.
Yes, actually, yeah. So you can even write down loop that way. Okay. So
Ma'am, in infinite
Excuse
loop,
me.
we can omit the test expression.
so you will be writing down 1 over here. So there won't even be 1000. So where is that for loop? As we already have discussed, so whenever this test expression is giving us any value which is not equal to 0, then we are going inside the loop. Okay, so if you write down 1 over here, okay, then always that test is giving us non-zero value. Okay, so always condition is being met and you are allowed to pass inside the loop. Okay, but break is being executed at this level, so it is anyway not going to run for infinite number of times, because at some or other point of time this break is going to come over there and it is going to break the entire looping, and then you are going to come out of this loop. Then the control is thrown out of it, okay, directly from this line, which is line number 41, and control comes out and is over here at line number 44. Okay, so that way also is possible. You can exclude that whatever that statement which was written over here. Okay, so that statement, conditional statement, can be excluded and you can write down any non-zero value here. Okay, it is 1, I can even write down 1000 or 100 or anything. So still it is going to do the same stuff. And it's 1, 1, 0, 2, 2, 5. Yeah. Able to appreciate it?
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt in for loop.
Please tell me.
Ma'am, when we write I plus plus, then how do we know that where I plus 1 is going to be added?
Okay, so I suppose that your doubt is something like this, right? So when to say plus, when to
No, no, ma'am. In which variable it is going to be added? Like here, h is changing to 2h, 3h.
See what happens. Okay, so I'll tell you. When you are coming inside the loop for the first time, at that time value of n is equal to 2. Okay, then for that n, whatever that is written inside the loop, that will be evaluated. Okay, and then this particular increment will be carried out. This increment is carried out after execution of whatever is there inside the loop. Okay, at the end of that, this increment happens, and once this increment happens, then once again this condition is checked whether the condition is being met or not. That is seen. If that condition is giving value as 0, then you come out of the loop. Otherwise, you don't come out of the loop and go inside the loop once again when the condition is anything other than 0. Okay, then when you go inside the loop second time, again everything, whatever statements you have written inside, those will be executed, and then the value of n will be incremented. After execution of all statements, value of n will be incremented, and it will be written as n plus plus. I mean, it is taken as n plus plus. Okay, incremented by 1. Once again, condition is being checked, and this keeps on happening. Clear?
Yes, ma'am.
Excuse me, ma'am.
Please.
Ma'am, for loop also takes condition, like we are writing 100 in it. So cannot we use FAPS condition over there also? Means
For loop takes, sorry, Parth, I did not get your question. Can you please repeat the question?
ma'am, like when we are writing a for loop for int n equal to 2, then some n less than some number and n plus plus. So ma'am, n less than is a condition, like you are, as you are telling, like it is the part between the two semicolons is a condition. So can we use like FABS condition over there if this condition gets violated, then the loop will come out.
Okay. You can. So this whatever that you have written inside, you write it over here? Is that what you mean? Yes, that is possible. So what you will be doing is you can define one variable over here which will take this, okay, whatever f app. You don't have to write down break statement. So that is also possible.
Ma'am, I actually checked it, so it's giving, means it is not giving that answer. That is the thing. So that is why.
Wait, I'll try doing it for you. Okay. So I will define one variable for that. I'll define one variable for that. Okay. And that variable I'll keep updating inside, and that variable value is something with whether that okay. So actually, I talked about Boolean variables?
No, ma'am.
Okay, I haven't talked about Boolean variables, right? Okay. So let me write down a variable called as check. Here, and let that check be a Boolean variable, and that check is updated every time. You don't have to write down this all stuff.
And the first time you wrote check, the spelling was wrong. It was CHECL.
I'll check it out slightly. Yeah, this is closing here. Okay, I have to define it as a Boolean variable. And I suppose this is how it is written. No. Boolean, what is the syntax?
BOOL.
BOOL, Boolean. Yeah. Boolean.
This was in the tutorial sheet as well.
Okay, fine. So Boolean variable is even a lower degree integer variable which can take only 0 and 1. So it has got only one bit associated with it. It can store either 0 or 1. Okay, so it's like a variable used to save output of a condition. So if condition, wherever you are using if condition, then output of that if will be either a 0 or 1. You can store that in some variable, and that variable actually don't have to use a big space, because anyways what is the maximum number that you are going to store in it? That is 1. And what is the minimum? Which is 0. So you need only space of 1 bit for that variable. So that's why those are called as Boolean variables, which can store only between 0 and 1. And I've defined that kind of variable over here whose name is check. and I am assigning check value equal to f abs f int minus f int previous smaller than tall. Okay, so this condition is going to return either 0 or 1. Okay, so whenever that condition is satisfied, that time you are going to get 1, otherwise it will be 0. Okay, so you are supposed to go inside the loop when this happens. Okay, you are supposed to come out of the loop when this condition is not satisfied, right? So you will have to define check in this way. Okay, the way we had defined it for do while loop. Are you able to appreciate that why I have flipped the condition over here? Is everybody able to appreciate this? Hello, am I audible?
No,
Yes, ma'am.
ma'am.
Yes.
Okay, fine. So, okay, it seems that some of you are not able to see that why I have changed the condition. Okay, so right now, when check will get value equal to 1, when difference between f int and f int previous is larger than tolerance. Okay, that time check is having value equal to 1. If that difference is larger than tolerance, then obviously you need to increment the number of segments that you are right now having and go for a new execution of f int, right? So whenever check is having value 1, then you can go inside the for loop and carry out that operation of incrementing and updating this f int, so which is happening over here. Okay, so check is having one value, which essentially means that it is a pass which can allow you to go inside for loop, and you are supposed to go inside for loop whenever f int is greater than f int previous. Okay, the moment f int is not greater than f int previous, that time check will get value equal to 0, and it won't let you go inside the loop, and further executions will stop.
Okay, ma'am, I got it.
Got it, right? And in each loop iteration, okay, so whenever I am executing that loop, so at each loop execution, I am updating check value. Okay, check value updation will be only between 1 and 0. Okay, it won't take any other value. Either it will take 1 or it will take 0. Okay, so here also I need to update it, and it should be using this condition. Let me run it. Is this clear? Although we have missed
Yes, ma'am.
printing number of iterations, but you can add those number of iterations here. Okay. So in order to add those number of iterations, you will have to access that variable int outside. So this int n should be defined here. Then only you will be able to access that. And I will only be writing n in this. I don't have to define it here. I suppose this will work. And when I come out of the loop at that time, number of iterations I'm printing over here, and that is equal to n. Now I'll be able to access that n over here. Let's try to check it out. There's some problem. We don't have to write down int in 2 times in the same line. Okay, so it has given me number of iterations as 64. Okay. The earlier condition was different. Okay, so earlier condition, we were checking when this was smaller than 12. That time we were going inside. Right now we are going inside till the time it is larger than 12. So there is one condition which stands exactly between these two, where it is exactly equal to 1. Okay, so for I guess that is one iteration which has been missed out, and because of which we are getting 64 as the output number of iterations which we have performed are 64. Okay, fine. So we are done with our today's class. In today's class, I have shown you how to use break statement. Okay, you can use the break statement to break any loop. Okay, not only for loop, you can write down break statement inside the while loop as well, or do while loop. Okay, so that works. That break you will be putting inside one condition. Only when you are putting inside the condition, that time itself it makes sense using inside the loop. Okay, otherwise if you write down without any condition, then right at the first instance that loop is going to get broken, which you obviously are not anticipating, and hence you will be putting it inside that condition. And then you have two parallel conditions, right? So one condition where we are checking it over here. Okay, that is one condition which decides when to break the loop, when not to continue the loop. And there is another condition which you write down for writing break. Okay, so you have two conditions, and these two conditions you can use in order to break the loop. Okay, so break is one control statement which controls the flow, how exactly program flow is going to be there, that is being controlled by that. Okay, otherwise when there was no any break in the previous case, that loop was running till the time n was taking value equal to 1000. But when you introduced break, okay, at that time wherever break that word was encountered, then that control was thrown out of this loop. And this act of throwing the control out of the loop is nothing but controlling that flow of the program, right? So that's why it is called as a control statement. Okay, so these whatever that you write inside if and all, those are called as condition statements. So this is condition statement, okay, where we are checking that difference is larger than tall. So that is called as a conditional statement. Then there are certain control statements. So break is one such control statement. If is also a control statement. If, when you write down if, then you decide when to execute that part which is written inside, right? So you decide where the control should be passed on after after this particular execution of that condition. So that is also a control statement. If is a control statement, but what you write inside if, okay, so which decides where that control has to go, so that is condition. So inside a control statement which is if, you write down a condition statement. Okay, so you have so far learned kind of control statements which are if, else. Then you also have seen for, while, do while. These are all control statements, and break is one control statement that I have introduced you to. And then there are two more control statements which we haven't yet talked about, which we'll be talking in the next class, which are continue and switch. Okay, so thereafter we'll be done with our control statements. Okay, and we also have seen this Boolean operator, not
Excuse me,
operator, this Boolean data, huh?
ma'am, in second for loop,
Hmm.
ma'am, where I is changed to I plus plus,
Hmm.
ma'am, where it is getting used.
It is getting used in order to decide how many number of times this needs to be carried out, right? So till the time I is incremented to 7, at that till that level, this thing has to happen. In order to determine how many number of times this for loop is to be executed, For that, you are using this I. I is a counter which decides how many number of times this for loop is being executed. For that, we are using I. Okay,
Okay, ma'am.
but we are not using that I inside, right? So we are not mentioning that I explicitly inside. You can either mention it or you cannot even, I mean, you need not even mention it. Okay, so it's not required that I should be in. I is in this case only controlling how many number of times this operation is supposed to be done.
Ma'am,
Mm-hmm.
the loops, ma'am, does it matter if we use post increment or pre increment as an updation statement?
It matters in certain cases. We may even see an example sometime. I'll show that when it matters. Okay, so I'll be showing you one example. So when if you have such kind of increment, then what happens? It matters indeed. Everything matters. So whatever that you will be doing over here, everything matters. But then there is always a workaround. Okay, so you can nullify that effect by some other mean.
Okay.
Okay.
Ma'am,
Hmm.
ma'am, if we omit this checking part, that is line 41, if we comment it, and in 27th line, instead of check, we write any number, then will the for loop go in infinite loop?
Yes, it will go.
Okay.
There is nobody to stop it, right?
Yes, ma'am.
Okay. So I hope you are done with your questions. Okay, so I'm stopping sharing my screen now.
Ma'am, you had given me the task to